Hey guys, really quick lesson on gradient. As we did our vocab a little while ago, gradient is slope. We're going to do a very short, quick lesson on gradient, and when we come back into school, whatever that is, into the building together, we will eventually go through gradient a little bit more deeply and thoroughly to make sure that we fully understand it before our final exam in June 2021. So if we take a look at a map like this with all these contour lines, these brown contour lines, remember we said when the contour lines are extremely close together, as they are in these areas here, that is a very steep area. So that would have a very steep gradient that we would say. And when they're spread farther apart, like up in here, we would say it would be pretty flat or not steep, be a gentle gradient. We can now calculate just how steep those areas are by using the gradient or slope formula. So I want to show you this here. This is Niagara Falls from a satellite view. This is the city of Niagara Falls in the United States. This is Niagara Falls in Canada. And this is Goat Island right here with the Three Sisters Islands here. This would be the American Falls, and this would be the Horseshoe Falls, which is the Canadian side. And you see all the rapids as you get there. What I want to do is kind of look at this area kind of right in here as I go to this map. And it says it doesn't work, but that's not entirely true. So I'm going to move this. And I'm going to show you right here. So like I said, this was Goat Island. And if I go from Goat Island right here, something you can't... Whoops. Oh, didn't want that at all. Okay, let me click it again. So I'm going to go right here, somewhere from Goat Island into the water here. And you'll notice it does look like there's a steep drop-off right here. They can't really zoom in any closer than it already is because it says it doesn't work. But this area right here, there are a ton of contour lines that are pretty close. So if I wanted to know what that area was like from A to B, if I would like to walk it, that would look like this right here. See that drop-off? It's a huge cliff. And that is the cliff right here. This is the American Falls. This is the Horseshoe Falls. That's that cliff that right at the edge of Goat Island. That's a huge drop-off right here. So that's what the profile would look like. But this drop-off, that steepness, we could calculate just how steep that would be. You see it goes from like 155 down to about 100 or so over a not very far distance. So we could calculate how steep that slope would be using the gradient formula that we're going to do next. So in your notes, guys, you'll notice you have some blanks. You're going to type in your answers. That's starting right now. So another way to express slope is gradient. Gradient is the average slope of a particular area on a map. Usually, they give you the 2 points. They don't always draw a line between the 2 points on a map, but this always gives you the 2 points. The formula for gradient is the change in field value over distance. Now, almost always, gradient is used for maps. So the change in field value really means the change in the elevation between the 2 points. What is that difference in elevation between the 2 points? How far are they separated? And you would divide that by the distance between those 2 points. Now this formula is found on your reference table, the first page of that reference table we mentioned a while ago, right there, along with a density formula. So it's not something that you need to memorize. So, like I said, it's found on page 1 of your reference table. Now field value is whatever the isolines on the map are measuring. Like I said, the elevation. And then distance is the actual distance between the 2 points given using the map scale. Every once in a while, they actually just give you the distance. But usually, you have to figure the distance out by using the map scale. So, here's an example you guys have here in your notes. You have this hill. I know it's a hill because the loops are getting smaller and the values are getting bigger. So, if I wanted to know what the gradient was between points A and B, here's how I would figure that out. Gradient is equal to the change in field value over distance. Now, many times on your final exam, they're going to want you to write out the formula because you get a point for it. So if you guys write out that formula, please. So the first thing I want to do is, what's my change in field value? Meaning, what is the difference between the elevation of these 2 points? Well, if I look, A has an elevation of 400 and B has an elevation of 200. Well, if I do 400 minus 200, obviously that would be 200. Now I got to figure out what my denominator is, and that is my distance. Now, in real life, what you guys would do is you would take a piece of paper and you'd hold your piece of paper up on your map, and you would hold it in between points A and B and put marks on each one of the where A and B cross that piece of paper. And then you take those 2 marks and bring it down to the scale down here and try to figure out how far that distance would be. Now, since this is all done remotely right now with no paper in front of you, it's a little difficult to do that sometimes because you'd have to hold the paper up to your computer, and that messes with your like dimensions sometimes. So if I take this red line right here that scans from A to B, I can take that red line and bring it straight down here, and you see it's 2 miles long. So what I would do is put 2 miles as my denominator. That's my distance. So my gradient then would be 200 divided by 2. 200 feet divided by 2 miles. Always need to keep the units. What would my answer be? If I do that math, 200 divided by 2 is 100 feet per mile. That's my gradient. So that means every 1 mile that I walk, I would go up or down, depending on the direction I'm going, 100 feet. That's not that steep. So in the second page of your notes there, I have an actual example from a Regents question. You see this is a great map, and they probably had multiple questions that went along with this map. It was probably a 4 or 5 question set at the back of your final exam when it comes to like the short answer questions. Here's just one of those questions that dealt with the gradient. So the directions, say letters A, B, C, D, and E on the topographic map shown below represent locations on the Earth's surface. Letters K, L, M, and N are locations along the Copper Creek. Elevations are measured in meters. See here, they also give you the contour interval in 10 meters. They got the scale right here. And they tell you that the depression contour lines, those lines with those little teeth marks, the Hatchard marks. So this is a great map. The question is, calculate the gradient between points B and C on the topographic map shown and label your answer with the correct units. Be sure to show all your work, including proper units. Express your answer to the nearest tenth. Now, it says B and C, guys, not D and E. See, D and E has a line connecting them. I think your brains instinctually would go to that, but D and E is not what we want to look at. We want to look at B and C over here. C is on the 50 contour line. So I actually gave you guys the formula already. I wrote it in there for you. What you guys are just going to have to do is type in the substitutions underneath. So B, C, that's what we want to take a look at. So gradient is the change in field value over distance. G is going to be equal to, well, B and C. C is on the 50 line. Well, what is B? Well, the value is the contour interval is 10 meters. So if I go down 40, 30, 20, 10. Why did I go down? Because we're getting closer to the ocean. Remember, the ocean is 0. That's 50 divided by 10. Now, if I actually, you can kind of almost see, guys. If I go 50 straight down here, C straight down here, it's a distance of 2 kilometers. So I would have 50 minus 10 over 2. That gives me 40 meters divided by 2 kilometers, which would give me a gradient of 20 meters per kilometer. Now that these notes are done, please submit this back into the assignment section in Schoology to get credit for it. Thank you.